Hello, I'm Xuanyan Xuanyan. Normal distribution is a basic concept in statistics and probability theory, and its applications are very wide in our daily life. I will use visualization method to explore some properties of normal distribution in this video. Now, let's look at the probability density function of normal distribution. This is a PDF of normal distribution. It looks a little strange since it is not as easy to understand as the PDF of the binomial distribution and the hypergeometric distribution. So maybe we can draw a graph to analyze it. According to the figure, we can see that the graph of the normal distribution is bell-shaped and symmetrical around the mean. Therefore, we can conclude that the mean, median, and the mode of the normal distribution are equal and located in the center of the distribution. Observing the probability density function of the normal distribution, we can find that the mean and standard deviation determine the PDF of normal distribution. When I control the standard deviation to be the same and change the mean, we can find that the shape of the graph does not change but only shifts. When I control the mean to be the same and change the standard deviation, we can find that the smaller the standard deviation, the steeper the curve, and the larger the standard deviation, the flatter the curve. However, this probability density function is not as easy to understand as those of binomial distribution and hypergeometric distribution. One kind of events in life will have the probability distribution, like the normal distribution. Maxwell's theorem will provide us with a direction to answer this question. Maxwell's theorem says that if the probability distribution of a random vector in Rn is unchanged by rotations, and if the components are independent, then the components are identically distributed and normal distributed. This means that if a distribution satisfies these two properties, 1. Leaves from the center become less likely moving away from it. 2. Leaves from the center along one direction don't condition ones along the perpendicular direction. The probability distribution of the distribution will be shown in the form of E minus x and actually the normal distribution. I'd like to provide an example to illustrate it. Assume that we are hit a target. We hit many times towards to the center of the target, so there are many points on the target to record the result of each hit. In the situation, we assume that the greater the distance from the center, the smaller the probability of landing at that point. At the same time, the coordinates x and y of the landing points does not affect each other. Then we get the picture of the hinting results. Next, I'll count all the points that lie on a line that passes through the center points and is parallel to the x-axis, and all the points that lie on a line that passes through the center points and is parallel to the y-axis, and analyze their distributions separately. They are shown as the two pictures below. We can see that their distribution could be approximately regarded as a normal distribution. As for y, the probability distribution of normal distribution is presented in the form of E negative x. It is also easy to understand. We can assume the probability of falling on a center point is equal to fr squared. According to assumption 2, since the coordinates x and y of landing points do not affect each other, since x squared plus y squared equal to r squared, fx squared plus y squared is proportional to fs squared multiple fy squared. Hence, the probability density function of normal distribution is presented in the form of fx equal to a times e negative b times x. Since each normal distributed variable has its mean and standard deviation, the shape or position of these curves will be different. To simplify and solve this problem, the concept of z-value is proposed, and this is the formula to calculate the z-value. And for example, we can change a random normal distribution to the standard normal distribution, like the below picture. Pearson's coefficient of squareness is a method developed by her person to find squareness in a sample using descriptive statistics as the mean and mode. Squareness is one method of the shape of a set of data, and this is a formula to calculate pi. A larger the value, the larger the distribution differs from a normal distribution. A larger negative value means the distribution is negatively squared, and correspondingly, a larger positive value means the distribution is positively squared. A value of 0 means no squareness at all. We can look at these pictures. When pi equal to 0.03, it is normal distribution. When pi equal to 0.95, it is right square distribution. When the pi is equal to negative 0.91, it is a left square distribution. We will note that If we have a large sample, calculate the probability of the binomial distribution will become difficult. So we will use the approximation to the normal distribution to simplify the calculation process. Now let's check the conditions of the normal approximation. First, n times p should be bigger or equal to 5, and n times 1 minus p should be bigger or equal to 5. Third, the trial results need to be independent of each other, and the probability of success p for each trial must remain constant. We'll prove that by visualization way. We can find that when n equal to 5 and p equal to 0.8, the shape of the binomial distribution is clearly skewed to the right, and the normal approximation does not fit well. And when n equal to 5 and p equal to 0.2, the shape of the binomial distribution is clearly skewed to the left, and the normal approximation does not fit well. When n equal to 10 and p equal to 0.5, the shape of the binomial distribution starts to match the normal approximation better, but it is still not perfect. When n equal to 30 and p equal to 0.3, the shape of the binomial distribution is very close to that of the normal distribution, indicating that the normal approximation is valid in this case. For convolution and normal distribution, I'll prove this by visualization way. We set z equal to x plus y. We can find that it is consistent with the probability distribution graph of a normal distribution. Finally, let's talk about the finite population correction factor. Correction factor is necessary when we choose samples without replacement from a finite population. I'll prove it through visualization way. Compare these two pictures, we can see that the correction factor is necessary to adjust the standard error. Thank you for your watching.